Hi, my name is James. I'm going to be talking about installation and operation of the Amazon grid tie inverters and solar power systems. Okay, we're going to start with the solar panels first. We've got 6 300-watt solar panels here, and these two here are tied in parallel, those two are tied in parallel, and the other last two are tied in parallel. And I just go through 3/4 inch aluminum flexible conduit down to the inverters. Okay, from the solar panels it comes down the wall in the flexible conduit. It comes down this way. 2 of the solar panels are connected up to this inverter, 2 are connected to this inverter, and 2 are connected right here. From the inverter, it just goes out in the power cord right here through a watt meter, and then the watt meter is plugged into the outside outlet of my house. These are the solar panel Z mounting brackets. Most people mount these solar panel and a deck type of screw going into the roof on this side right here. I'm using actually 2 of them together. I mount it this way and then the deck screw right here so that I get more ventilation under the solar panel. Okay, on mine I'm going to mount Z bracket directly onto the roof. You need to check with your local area codes and the building and safety to find out what your exact code is, but this is how I do it in my area. And so all you have to do is just put wet patch all over the bottom. We're going to get a roof replacement pretty soon, so I'm just going to show this as an example of what to do. So I've got 6 pairs of these Z mounting brackets. What you do is you put the wet patch under all 6 corners of it and then set it down. So all you do is just screw it in. Okay, and I've got 2 of the 300-watt solar panels in parallel. Positive and negative are going to be connected in parallel with each other, and they're at 32 volts. So instead of 300 watts, I'm going to get 600 watts. And so I've got an MC4 Y branch connector. So all I do is connect up on the negative side of one solar panel, negative side of the other solar panel. And these MC4 connectors are real nice, they're real easy to use. Then I just plug into the negative, and this part's going down to the inverter. And then on the positive side of the Y branch connector, I plug that into one solar panel, into the other one, and it just puts these in parallel. On the flexible conduit right here, what you do is you use one whole strap, and these will mount these onto the wall. And on this side right here, just to make a smooth transition, what I did is EMT to flex 3/4 inch. They just screw into the conduit. But make sure and check with your building and safety in your local area. If you're bringing it up to code, you want to follow what's required of your area. So we have the 8-gauge MC4 solar wires coming through the flexible conduit right here. And these here, you can just push these through. I made it 8-gauge because I'm going 25 feet. If the wire's not thick enough, and then it's going to lose some of the power from the solar coming to the inverter. So I made it 8-gauge. If you're a shorter distance, you could go 10-gauge or you can go 12-gauge depending on the power level and how far you are away from the solar panels. The MC4 cables need to be stripped and a lug put on there. This is the lug I use on mine. This is for 8-gauge wire, and it's got a 1/4 inch hole. I'm going to give a parts list at the end of this video, and I'll give a description of all the parts I used in my setup. So I strip this around here, and I pull this off of here. And I put the lug in the clamp, and it's sort of got a notch there, and it notches onto the wire, and I push the wire in as far as I can, make a really tight connection, and then crimp it really tight. Okay, always verify polarity on these. I mean, I know red's going to be positive, but it's good if you're not sure. You know, down here I had to use 2 black wires, but make sure positive goes to positive, negative to negative. Make sure solar panel is disconnected when you hook these. Hook it up on this side right here. I put the washer and just screw it on there. This box right here, this isn't really necessary. I know people who've actually put these inverters underneath the eave of the house. It just goes inverter, MC4 cable straight up to the solar panels, and then an extension cord plugged into an outlet. The grid tie inverter has actually got intelligent control where if the power on the line is disconnected and then the grid tie inverter turns off. And that's a safety feature, and the power companies actually require that because they don't want you to keep putting power onto the line if their grid goes down and a technician's working on it. And that's also got the phase and the load automatically synced with the line input. So that's the way it works. As you're putting DC in here, it's putting AC out on this side. And if your house is using all the power out of this, then it just goes to your house. If your house is not using all the power of this, and say this one here is 450 watts at maximum power in the middle of the day as the sun's shining bright. If your house is not using 450 watts, this is going to put power back on the grid. Putting it back onto the grid is a good thing, and I have a friend of who has these, and he's got two of them at two different houses, and his meter actually spins backward. So as he puts power back in the grid, he actually got a credit of $6 on 1 month because he was putting power back onto the grid. The problem is that it really requires a net meter, it's called. And if you don't have a net meter at your house, or also one of the old-fashioned meters where it spins and it's got the motor, a lot of the newer digital meters, especially the F9 meters, do not do net metering. So the problem of that, the thing that happens is that if your house is not using all the power this is putting out, and it goes back onto the grid, instead of giving you credit for it, they actually charge you. The meter's counting up as the power is going through the meter, because the meter is just seeing power go one direction or the other. It doesn't matter which way it's going. So these inverters I've got inside of a cement mixing tub. I drilled holes in the side, I put screens. It's important having these enclosed in a clean area because it's got intake fan, exhaust on the other side. You want to keep them clean, but then also it's got to have ventilation on it too. And so this is aluminum shielding. It's used on roofing. I put these in back of them, and I used a conductor compound. It's this white grease right here, so it transfers heat off of them. So grid tie inverters like this are really plug and play. You just plug them in, and everything syncs up automatically. The output's kind of interesting. You plug this into a wall socket, but mine, I plug into a power meter. So I just plug it in right here, and then this one plugs into an extension cord. So I put it right here. This kilowatt meter I bought separately, and so this is really cool because these will measure power if it's going out this way or also if it's going back onto the line. And all you do is just plug it in, and it's got all these different scales on here. So if I want to measure volts, it's saying 123, so it's measuring line voltage of my house. It tells me how many amps, and see it's got 0 amps. I've got this off. It's too noisy with the fans on if I'm recording. I usually leave it on this scale, which is the watt scale. And as I mentioned, it goes up to about 450 watts in the middle of the day. The frequency it's got there, and then this here is how many watts it's used over a period of time. Every time you unplug it, it resets. So I just unplugged it so it reset to 0. Here's a quick rundown circuit diagram of my grid tie solar system. So up here we've got 2 of the 300 watt solar panels. They're in parallel at the 32 volts DC, which comes down here. Current is calculated by power divided by the voltage, so it's actually 450 I've got at the max power, so 450 divided by 32, so 14 amps DC coming into the grid tie inverter. Comes out as AC, it goes into the watt meter right here, and then it plugs into the AC outlet.